Hi Pre-Calculus, welcome back. Today we're on 4.3a, evaluating sines of trig functions. So today we're essentially going to be extending SOHCAHTOA to all angles and not just acute angles, okay? I'm going to force a pause on your screen to make sure you've got everything on your checklist before we go. Alright, so I've got a definition on the screen as well as a little sketch. I'd like for you to copy my screen. I'm going to force a pause one more time. Okay, so let's read this definition together. It says, let theta be an angle in standard position with x, y, a point on the terminal side of theta, and r, which we're going to figure that out in just a bit. We define the following as, so we want to try to find sine of theta, cosine theta, tangent of theta. Now that theta might not be acute anymore, so you can see the theta I've drawn is now in quadrant 2, okay? So the way we're going to do this is really look at the reference angle, okay? So you remember what the reference angle is. The reference angle is the acute angle made with the terminal side and what? The terminal side and the x-axis, okay? So let's say I've got this point, x comma y. I'm going to, here's my terminal side. I'm going to connect that to the x-axis. So I'm now going to look at that right triangle, okay? So if that terminal point is xy, I'm going to call this leg x and this y. And I'm going to call the hypotenuse r. And how could I find r? I could use Pythagorean theorem, right? So I'd have x squared plus y squared equals r squared. In other words, r, and I'm going to assume r to always be the positive root. So r is going to be square root of x squared plus y squared. So notice that r is always positive and it's never 0, okay? So now if I use kind of that reference triangle, we can now define sine of theta, cosine of theta, and tangent of theta if I look at that angle there, okay? So if I do sine of that angle, it's going to be opposite over hypotenuse, in other words, y over r. Cosine is adjacent over hypotenuse, in other words, x over r, and tangent is opposite over adjacent. So in other words, what do we get there? Y over x, okay? Now when you're doing these, just really make sure that you watch out for signs because now x and y could be negative. They're not always positive, right? However, r is always going to be positive. Okay, so let's try this example together. Please write in your notes what I write on the screen. So we're going to find the 6 trig functions of the angle determined by the point negative square root of 3 comma negative 1. So let's go ahead and draw that point out. Can you tell what quadrant that point is going to be in? Yeah, it's going to be in quadrant 3 because I'm going left and down. So I'm going to go left negative square root of 3 down negative 1. So I'm going to end maybe right around there. Now here's the important part. Make sure you, of course, connect that to the origin. There's my angle. And now connect always to the x-axis. Remember that to find your reference angle. So now I can use this as my theta right there. Okay, so let's write out first the original 3 trig functions. So sine of theta, cosine of theta, tangent of theta. So you've got your x and your y, in other words, excuse me, your opposite and adjacent. Now how could I find the hypotenuse? We can use Pythagorean theorem, right? Square root of negative square root of 3 squared is going to be positive 3. Negative 1 squared is 1, so square root of 4 is 2. Okay. So sine of theta, y over r, also known as opposite over hypotenuse. Cosine adjacent over hypotenuse, and tangent opposite over adjacent. So I could write that as 1 over square root of 3. I get the question a lot, do I need to rationalize? For me, no, you do not need to rationalize. Now, if you're in my math lab, you really need to make sure you read that fine blueprint because sometimes they ask you to rationalize and sometimes not. So just be sure you read directions, okay? Now, if you did want to rationalize, remember multiply top and bottom by root 3. So you get root 3 over 3 in this case. And the reason we really don't care about rationalizing anymore, first of all, I don't think 1 is necessarily like simpler than the other. The whole reason rationalizing was a thing was because before calculators, people would have to look up these square roots in a table, and it's a lot easier to divide by 3 than it is to divide by some long decimal, okay? So that's where rationalizing the denominator came from. We really don't need that anymore, do we? Okay. So what about the remaining 3 trig functions? So for the remaining 3, reciprocal of sine is what? Cosecant, right? I try to remember, pair up s's with c's. So reciprocal of sine is cosecant, so I'm just going to flip. Negative 1/2, so that's negative 2. Reciprocal of cosine is what? Is secant, so remember, match c with s. So if I flip that, that is going to be negative 2 over square root of 3, also known as negative 2 square root of 3 over 3. And then reciprocal of tangent is cotangent. And I'm going to flip that one. All right. So it's really important that we know the signs of trig functions, in other words, SI, G, and S. So what I'd like for you to do is just quickly draw a little XY axis there. And what I'm going to look at is what's the sign of X, what's the sign of Y in each quadrant, okay? So if I'm in quadrant 1, I go to the right and up to get to quadrant 1. So both X and Y are positive. So can you do a little plus, comma, plus in that quadrant for me? In quadrant 2, I would have to go left and up. So X is negative, Y is positive. In quadrant 3, I have to go left and down, so negative, negative. And what do we get in quadrant 4? I have to go right and down, so positive, negative. Okay, now what I want to try to do is figure out which trig functions are positive, which are negative in each quadrant. Okay, so if a trig function is positive in that quadrant, I'm going to put a little check. If it's negative, I'm going to put an X. I think you'll see why in just a bit. So let's start with sine of theta in quadrant 1. So remember, sine is y over r, and remember that r is always positive. In quadrant 1, y is positive, so I have a positive over a positive, which is a positive, so I'm going to put a little check there. All right, still in quadrant 1, moving on to cosine. I have x over r. Well, x is positive in quadrant 1, r is always positive, so I've got a positive over a positive, which is positive. And then the same thing for tangent, right? I've got y over x, both are positive, so tangent is positive in quadrant 1. So I've got that all 3 trig functions are positive in quadrant 1, so I'm going to put an A for all. They all got check marks, okay? All right, let's move on to quadrant 2, where x is negative, y is positive, and remember, that r is always positive. So if I've got y over r, I've got a positive over a positive. So that gets a check. X over r, that would be a negative over a positive. So that's a no. That is not positive. Tangent y over x, I'd get a positive over a negative. So that is no, not positive. So the only one that got a check for quadrant 2 was which one? Sine. So I'm going to put an S for sine being positive in quadrant 2. The other 2 are not. The other 2 are negative. Okay, moving on. Let's take a look at quadrant 3. X is negative, y is negative. So if I've got y over r, a negative over a positive, that's a negative, so that gets an X. Cosine, negative over positive, so no. But tangent, I negative over a negative, that is positive. So that gets a check mark. So the only positive trig function out of these 3 in quadrant 3 is tangent. So I'm going to put a T there. All right, last quadrant 4. See if you can do quadrant 4 on your own. Okay, so the only positive trig function out of these 3 in quadrant 4 is cosine, since x is positive and y is negative. All right, so let's try example 2 together. Could you write this interval in your notes? 3 pi over 2 comma 2 pi. And then could you also write sine of theta, cosine theta, tangent theta? All right, so we want to know the signs, either positive or negative, of sine, cosine, tangent of theta, where theta is in the interval 3 pi over 2. If you'll remember, and you can convert to degrees if you need to, 2 pi is a full rotation, 360, right? But 3 pi over 2, and again, convert if you need to, is 270 degrees. So from 270 degrees to 2 pi radians, or 360 degrees, we are in quadrant 4, okay? So for quadrant 4, and remember we had, oh my, all sine, tangent, cosine, right? So in quadrant 4, only cosine was positive, so I'm going to put a plus for cosine. The other two would have to be negative, okay? And that's all. We do have a nice little acronym for this. This is how we typically remember it. We do all students take calculus, okay? So just go in quadrant 1, 2, 3, 4, A, S, T, C, okay? All right, let's try the last ones here. Can you write these two in your notes, please? Sine of 271 degrees and tangent of 7 pi over 6. Let's do number 1 together, and then I'll have you do number 2 on your own. Okay, so without a calculator, let's determine whether these would be positive or negative. So 271 degrees, that is going to be in quadrant 4, right? So all students take calculus. Only cosine is positive in quadrant 4, so sine must be negative. So I'm going to put less than 0 there. All right, try number 2. If you need to convert to degrees first, by all means do so. All right, answers on the screen. 7 pi over 6 radians is equivalent to 210 degrees, which is in quadrant 3, and tangent is positive in quadrant 3. All right, that's all we have for you today, y'all. We'll see you next time. Bye.